from the right, now and they are the same value, we can say the limit exists. So what does that look like in notation? So what we say is we would say the limit as x approaches some random value from the left equals the limit as x approaches that same value from the right. Then we would say the limit as x approaches c exists. Okay? So if they approach it from the left and the right, and they are the same y value, remember, we're looking at the y values. We are not looking at the x values. Okay? Now, this is what we're doing when we're trying to find limits. Okay? We're using graphs. We're taking a look at different things. But now, what would you do if I gave you a table instead? Okay? So let's take a look at this same graph, okay? Or the same function. So let's use the same function we just did. So let's use f of x equals x squared minus 4 over x minus 2. And remember, x cannot equal 2. But I'm going to have you fill in a table of values, okay? Because sometimes in the AP test, they're not going to give you a graph. They're actually going to give you a table of values that they want you to work with instead. Okay? So here is our table of values. And what we're going to do is we are going to approach 2 from the left, and we're going to approach 2 from the right. Okay? Now, this is going to be our x values, and this is going to be our f of x values. So you're going to end up using your calculator to do some calculations here. So what we're going to do is we're going to set up the table first, and then I want you to pause the video, and then I want you to use your calculator to figure out the f of x values and just try to figure out what happens. So let's approach it from the left. So if we're going to approach it from the left, we're going to start picking some f of x values that are going to get closer to 2. So or some x values that get closer to 2. So I'm going to start with 1.5. Then I'm going to go to 1.75. Notice I'm inching closer and closer and closer to 2. Then I'm going to do 1.9. Then I'm going to do 1.99. And then I want you to do 1.999. Okay? Notice that these x values are getting closer and closer and closer to 2. Okay? But I'm coming in from the left side. Now, let's go to this one. I'm going to start out here with 2.5. Then I'm going to get closer to 2. I'm going to do 2.25. But then I'm going to keep getting closer. I'm going to go down to 2.1. And then I'm going to go to 2.01. And then I'm going to go to 2.001. Okay? So what I want you to do is I want you to stop the video, and I want you to calculate all of these f of x values using this function up here. Okay? Welcome back. Now that you've calculated all of your values, I'm just going to put some of the values in and just kind of review with you when you plugged it into your calculator. Hopefully you did these things and you could kind of figure them out. So this value should have been 3.5. Now, I'm just going to go through how to do this calculation on your calculator and making sure that you understand you need to use parentheses for things. Okay? So in your calculator, this is what you should put. Remember, the numerator needs to be in parentheses as a whole. Okay, so in your calculator, make sure there's a set of parentheses for the whole numerator. Now, what I tend to do is I tend to put whatever x value is being squared, I put that in a set of parentheses as well. So in my calculator, this is what the beginning thing is going to look like. And then I have -4. And then I'm going to use the division sign. And then I always like to put parentheses around the whole denominator as well. And in that parentheses, I'm going to put x minus 2. If you set it up this way, this is the value you should get. Now, I'm just going to give you the rest of the values. It's 3.75, 3.9, 3.99, and 3.999. Okay? Now, as we start over here and we get closer, this one was 4.5. Then we got 4.25. Then it gets to 4.1, 4.01, and 4.001. Okay? Now, if you plugged in 2, which you had to, you should have gotten this. Okay? So, I want to ask you a couple quick questions. So, I'm going to write these down. What is the limit as x approaches 2 from the left side? Well, take a look at all the numbers. What are these numbers getting closer and closer and closer to? We are always looking at the y values. Now that I've calculated, I don't care what's happening with the x values. What are these ones getting close to when I get close to here? Notice 3.999 is getting closer to 2. So my limit as I approach 2 from the left is equal to 4. Now, let's take a look at the other side. What is the limit as x approaches 2 from the right side? So when I am taking a look here, I approach it from the right side. So I start here, and I get closer and closer and closer to 2, but I'm not going to 2. What do you notice is happening to these values? 4.5, 4.25, 4.1, 4.014. Notice this is also getting closer to 4. So, does this limit exist? Yes. Even though at x equals 2, it doesn't exist. That number doesn't exist. The value doesn't exist. It does have a limit. Its limit is 4 because we are not going to 2. We are getting closer to 2. That's the big difference. You need to understand that limits are just getting closer and closer and closer to a value, but not exactly at the value. Okay? So, if there are questions at any point in time while you're doing this, send me some emails, things like that, and we will kind of talk, kind of work our way through some of those. So this is what a limit is. We have limits approaching from the left, we have limits approaching from the right, and they exist sometimes and they don't exist other times. So I do want to show you, before I move on, I do want to show you a limit that doesn't exist. Okay? So I'm going to draw a sketch of a graph, and we are going to take a look at this graph and talk about the limit from both the left and from the right. This one also, we're going to use 2 as our weird little spot. So x equals 2. And one of the graphs is going to come to here, and we're going to have an open dot. And then one of the graphs is going to start up here, and we are going to have a closed dot. Okay? So this is the graph of a limit that does not exist. So this limit does not exist. Okay? But let's talk about what that means. So let's find the limit as x approaches 2 from the left. Okay? As we approach from the left, we're always using x values going this way. So as I approach this function from the left, I do need to put a value in there. You do need to know that this is -4. Okay? So the limit as we approach 2 from the left is -4. Now, what is the limit as we approach 2 from the right? Okay? So, as we approach it from the right, we are approaching 2 from this side and in this direction. So I'm going to follow along this graph, and you're going to notice that this goes to a very different spot. This doesn't go to -4. This one goes to +4. So the limit as x approaches 2 from the positive side is +4. So what we would say here is the limit does not exist. Okay? So we've now seen multiple situations where the limit exists. We've also seen situations where the limit doesn't exist. Okay?